Hello students, in this video we are going to do a few more problems. You look at this question, this is another special type. You have x, y, z, x, y, z, y, z, y, z, zx, xy. So it's sort of cyclic order we have, but you are supposed to prove this as x minus y into y minus z into z minus x into xy plus yz plus zx. So I look at the right hand side, what is asked to be proved. So I need y minus z, z minus x, x minus y. So when I want to get y minus z, I know I need to subtract these two. Suppose I want z minus x, I need to subtract r3 minus r1. So I am going to take the left hand side and apply r2 is interchanged to r2 minus r1 and r3 is interchanged to r3 minus r1. We are not going to use anything else because we are very much used to this operation. So, and I am trying to teach you in a similar way you can get all the answers. That is the reason. Okay. So the first row becomes x square y z. So when I subtract r2 minus r1, y minus x, y square minus x square, zx minus yz. Coming to the third row, r3 minus r1. So z minus x. So z minus x, z square minus x square, xy minus yz. So we have subtracted now. And now, are you able to understand? I am going to factorize as much as possible. X square, x square, yz. This is y minus x. This is y minus x into y plus x, because you know a square minus b square is a minus b into a plus b. And the last one, z is common, so you get x minus y. So if I take z common, I get x minus y. Coming to the last row, z minus x, same way, z minus x into z plus x. And what is common? Y is common and x minus y, x minus z. Now, can you identify in the second row, x minus y is common, but if I put a minus for this, x minus y can come outside. This x minus y, if I take out, negative 1 will come. Okay, so I am going to do that step now. So from the second row, x minus y is taken out. From the third row, z minus x is taken out. So what will be left out? X square, y z, first row untouched. I have y minus x here, but I took x minus y. So are you able to understand minus 1 will be left out? Because y minus x is nothing but negative x minus y. So if I take x minus y out, minus 1 will be left out. Here, same way, minus y, minus x, and here z. Last row we are taking out z minus x. So 1, z plus x and x minus z. So is this step clear for you? Now, I can apply the expansion. Yes, because I have applied the property 2 times. It's enough. But I'm going to apply it once more because I know when I add these two, it is becoming 0. So I'm going to apply R2 is changed to R3 minus R2. So I'm going to apply R3 is changed to R3 plus R2, because minus 1 and plus 1 was there. Okay. So when I apply that, already x minus y was there, z minus x was there. First row is written as it is, x square, y z. Second row is as it is because I am only changing the third row. And the last row becomes 1 plus minus 1 is 0 and z minus y plus x plus y will be left out. So y gets cancelled. So what is left out? Z minus, sorry, minus. Z minus y will be left out, and here also z minus y will be left out. So this is same as x minus y into z minus x into, in the last row z minus y is common, take it out. So what is left out? X square y z. Second row is untouched, minus 1 minus x minus y z. Last row we have taken out z minus y, so it becomes 1 1 1. Now I am going to expand this determinant. Listen very carefully. I am going to expand along row 3 because it has 1 1 and then 0. Okay, so I am going to write here x plus sorry, x minus y, z minus x, z minus y into bracket open, 0 into, I am not going to write. What is the sign convention? Plus minus here. Okay, so minus 1 into, what is the small determinant? X y z, negative 1 z. And for this element, sign convention is plus. So plus 1 into, the left out determinant in which 1 is not there is x square negative 1 minus x minus y. Now I am going to just do AD minus BC for both the determinants. I'll write it in the next page. So this is same as x minus y into z minus x into z minus y, open the bracket, minus was outside, so keep it as it is. Finally we will take it inside. X z minus 1 into y z is minus y z, but it will become plus because AD minus BC, and then plus. Now multiply this, minus x square minus xy and then plus x square. Just the determinant is expanded. So this is same as x square and x square will cancel. So I get x minus y into z minus x into z minus y into minus 1 into x z plus y z. Minus is taken out of this also, so I can say plus xy. Now this minus 1 I will adjust with this because the proof says x minus y, y minus z, z minus x. Okay, so the minus goes off and this I'll write it in order xy plus yz plus zx. This is your right answer. So when it is in cyclic order or any other type of questions, you need to look at the answer and you have to follow the answer. If x minus y is there, try to get x minus y by doing r1 minus r2 or r2 minus r1, whatever is applicable according to the answer. Hope it is clear for you. So how will you attempt this question? Apply the property at least 2 times, and if you want you can apply it many more times to get the answer very quickly, or after that you can expand it and complete the factorization. Hope it is clear for you. Now we are going to do one more concept in this now, very important. It comes in 1 mark for you all the time. Suppose you know if the matrix is 1 2 3 4, I know if I multiply this by 2, what will I get? 2 4 6 8. Understand? Okay, but when I am given determinant of 2 4 6 8, I can take out 2 from the first row, which becomes 1 2 6 8, and again I can take 2 from the second row. Agree with me? Because in a determinant I can take out from each row if there is a common factor. So times the matrix A. Okay, but when I do the determinant value of it, it will become 4 times determinant A if it is a 2 by 2 matrix. Same thing if it is a 3 by 3 matrix. Suppose I do 2 times determinant of A. So from first row 2 will come out, from second row 2 will come out, and from third row also 2 will come out. So it becomes 2 cubed determinant of A. This is one of the important board questions which come in the examination. They will give you, let A be a square matrix of order 3 by 3. So order of the matrix is 3 by 3. Then determinant of Ka will be equal to K cubed into determinant of A. Because from each row 1K is going to come out. Do you understand that? And also remember, determinant is a value attached to the matrix. So the two important differences are, determinant, if you evaluate it, it is just one number, whereas matrix, with matrix, how many ever entries are there, all will be there, and determinant is defined only for square matrices. Hope everything is clear for you. In the next video, we will do area of a triangle.